In today's lesson, we're going to learn about normal distributions and z-scores. First, let's start off by defining what a normal distribution is. It's a bell curve that shows how data is distributed from the mean. Bell curve comes from its shape, as you see in the picture below, and it's going to be distributed around the mean. Remember, when we talk about mean for data, it's always going to be talking about the average. So our mean in the graph is here. It looks like a U, but it's actually mu. It's Greek, and that's going to be standing for the mean. Over here, what looks like an O is actually a sigma. That is going to stand for our standard deviation. Some important facts we want to remember about this normal distribution is as follows. About 68% of the data falls within one standard deviation of the mean. How I got this was I went to my normal distribution up here and looked at the 34% and the 34%. When I add those two together, I get 68. How did I know to add these two together? Because one standard deviation's there and -1 standard deviation's there. So that's my cutoff point. That is going to be where 68% of the data falls, within one standard deviation above my mean and below my mean. When I look at the next kind of blue section, I go to about 2 standard deviations. So now I'm 2 standard deviations above the mean at this line here, and 2 standard deviations below the mean at this line here. Adding up all of these percentages, so let me show you what I'm talking about. I'm adding up all the percentages from that -2 standard deviation to the +2 standard deviation. That's going to give me 95% when I add up all those percentages. That's going to be the 95% of the data falls within 2 standard deviations of the mean. For the last one, I got to go 3 standard deviations out. That's going to be out here at the 3 standard deviation and below my mean 3 standard deviations. Well, when I add up all of those values, so let me show you, I'm going all the way from -3 standard deviation to +3. When I add up all the percentages in my normal distribution, I get 99% of the data falling within 3 standard deviations of the mean. What's left is 1% in that yellow we are not including right now. That is our normal distribution. Let's look at an example, kind of with better numbers to kind of see what we're talking about with this normal distribution. So as you notice in this diagram, I still have the same numbers. These numbers do not change. These percentages stay the same. What does change is my mean. My mean in this problem, what I'm putting in the middle of my graph, is going to be 81. Why? That's what the problem gave us. It said the grades on a statistics midterm are normally distributed with a mean of 81 and a standard deviation of 5. So right away my mean goes in the middle. That is going to be 81 here. That's the middle of my normal distribution. Now, it says I have a standard deviation of 5. So what that means is that each time I hit a standard deviation, I'm adding 5 or subtracting 5. So if I'm going to the right here, I would add 5. So 81 plus 5 gives me 86. Then let's keep going. 86 plus 5 would give me 91. And then last but not least, I get to 96. I only go up 3 standard deviations and below 3 standard deviations. That's just how our normal distribution curve works. So now, instead of adding 5, I'm going to subtract 5 to go below my mean. So 81 minus 5 will give me 76. Then I subtract 5 to get to the next standard deviation, and I subtract 5 to get to the third standard deviation below my mean. So looks just like our normal distribution on the first page. I'm just now putting in numbers based on the grades we were given in this problem. So let's answer the questions. What percentage of the data falls between 76 and 86? Well, let's go ahead and shade that in. From 76 to 86, well, that's going to be everything in here. So 34 plus 34 would be my 68%. All I'm doing is adding the percentages that are always in there. Remember, those never change. You can keep them the same when you're talking about a normal distribution. What percentage of the data falls between 71 and 91? Well, let's go ahead and shade that in. So we are going from 71 to 91. Well, I have the 68 still, percent. That's shaded in the middle, but I'm adding the 13% plus 13.5%. So here we go. 68 already highlighted, plus 13.5, plus another 13.5%. Well, that is going to be my 95%. Okay, let's keep going. What percent of the data falls between 81 and 91? So I'm going to erase some of my highlighting here just to clear up my graph a little bit more, because I need to go from 81 to 91 now. And let me write back in this 76 that was erased. Okay, so from 81 to 91, let's use green now. 81 starts here to 91 here. Well, I shaded in the 34% and the 13.5%. So what do? Add them together. 34 plus 13.5 is going to give me 47.5%. Last but not least, last problem says what percent of the data is less than 86%? Well, two ways I could go about this. I could add up everything I'm going to shade below 86%. Or from 100%, I could just subtract what is to the right of it. But let's add everything up below. Adding everything up below, I'm going to get 84%. How did I get that? I added 34 plus 34 plus 13.5 plus 2 plus 0.5%. Adding that all up got me 84%. So that's saying if I got a score of 86 on the midterm, whoa, less than that. If I got less than an 86 on a midterm, that's 84% of my data being accounted for. Now let's talk about z-scores. So let's define z-score first so that way we know what we're talking about. Basically, a z-score is going to show how many standard deviations a value lies from the mean. So when we go back in our notes to the first normal distribution we were given, the mean was here in the middle. Oops, didn't mean to erase that, meant to circle it. The mean is in the middle. Then over here we had one standard deviation, we had 2 at this mark, and 3 at this mark. But we need to account for the continuation of this. There's going to be 1.2 here and more decimals between 1 and 2. Same thing with 2 and 3. You're going to have all the decimal possibilities between that. So our z-score is going to account for kind of the in-between points, because we don't want to say it's just 1 or 2 standard deviations. It might be a decimal in between. So here's our formula of how to solve it. Z equals x minus mu over sigma. One big thing, if you're not using Desmos, make sure to put parentheses around this x minus mu. That way the calculator will do that first before dividing by the sigma value. Let's go over what these x, mu, and sigma are again. X is going to be the specified value. So the specific value we're going to be giving. We'll go over that in a second, what that looks like. Mu is always going to be the mean of our data, and sigma is always going to be the standard deviation of our data. Okay, Let's go ahead and try example 1. Example 1. The grades on a statistics midterm are normally distributed with a mean of 81 and a standard deviation of 5. We want to find the z-scores for each of the following. Well, right away, let's kind of color code and label what we were given. We were given the mean was 81. So on my statistics test, the average for the class was 81. That's pretty good. Pretty good. Then the standard deviation is going to be 5. What that means is that's kind of my curve, how spread out it is. So to my next standard deviation, it's going to be 86. That will be one standard deviation above. And subtracting 5 from 81, one below, would be that 76. So that's just telling me how spread out my scores were. So let's go ahead and find the z-scores of the following. Say I got a 65. That's not pretty good, but it's still passing. So a 65, we go ahead and plug it on in. Z equals, well, x is my specific value, which is going to be 65 in this case. That was my score. And then the mean was my 81. And I divide after by my standard deviation of 5. I go ahead and type this into Desmos. So I go ahead, put the fraction bar in. I had on top 65 minus 81, and I put it over 5. That's going to give me negative 3.2. That's okay to have a negative z-value, and it makes sense in this case because you were below average. The average score on the test was 81, and you were below it. You were at a 65. Let's go ahead and look at problem B. Same formula, but now I have 83 I'm plugging in. So let's kind of use my colors here. I have 83, which will go here into my x. And then my blue is going to be my mean. I'm going to subtract my mean from my value. And then I go ahead and divide by the standard deviation of 5. So let's color code it. This 81 came from being my mean, and then my 5 came from being my standard deviation. Awesome. So when I type that in Desmos or put that in the calculator, I get 0.4. So that's not far off from the mean, which makes sense because 83 is not far off from 81, but it's positive because it's above the mean. I scored above average. Last but not least, what about an 100? What if I got 100 on this statistics test? Well, same formula. I'm just now changing out what my yellow value is. So as you see, each time I kept that 81, that blue, which was mean, blue, and then I kept that 5 every single time across the board. But what changed was my specified value, what I got on my midterm. So once I do this out, my answer comes out to be 3.8. So I'm 3.8 standard deviations above my mean, which is pretty high. Means I'm far out from that mean. Awesome. Let's go ahead and try another example to help us out. The following set of data represents heights in inches of the Greenwood High basketball team members. So we're measuring in inches. Find the z-scores for each of the following. Well, real quick, I'm not given the mean or the standard deviation, so I'd have to solve for them. So what I can do is I can go to Desmos and have it calculate that for me. You won't have to do this, but just in case you did, you would type in or actually pull up the function that looks like stats standard deviation right here. So I put in all my values. I have 76, 66, 67. I'll keep typing them in because these were all the values that were given to us in the problem. So it's more time consuming if it's not given to us, but still doable. And this will calculate the standard deviation for us. Awesome. So my standard deviation looks to be about 3. I'll round it to 3. Works out for me here. So let's write that down. My sigma, my standard deviation, is going to be about 3. Okay. Super great now I can get rid of that standard deviation and keep all these data points in, right? Don't have to type them in again. Because I can now find the mean. It's going to be 71.62. Again, I will round up to 72. So again, if you are given data and not the precise mean and sigma, go to Desmos, go to the keyboard down here, and functions, specifically statistics, where you find mean and standard deviation. All I did was type in all the values with commas between them to get my answer. Okay, so let's go ahead and solve this now. So I am 66 inches tall. That's definitely not true, but say I was. That is my specified value, what will be going in for x. So z equals 66. Then I subtract my mean. Well, that was 72 inches. Then I divide by my standard deviation, which was 3. That is my setup for this problem. So again, x, don't forget the formula was back on the last page. My standard deviation was 3, and then my mean was 72. Okay, I go ahead and do this in Desmos or a calculator. My answer comes out to be -2. Again, it's negative because it's below average. 72 inches is average for the basketball players on this high school team, and this height is 66 inches. That's definitely below 72. Now go ahead to 73 inches. Say I was that tall. Again, not true, but let's plug it on in. Same setup, except I'm changing out the 73. Instead of 66, that comes out to be 0.3. Awesome. Last one. Say I was 80 inches tall. Again, not true. I type that in, subtract the mean from it, and divide by my standard deviation of 3. My answer comes out to be 2.7. And that is how I find my z-scores.